Okay guys, let's begin the discussion of the questions. First question is giving you the value of f, x is not equal to a, the value which should be assigned to f at x equals a so that it is continuous everywhere. Okay, so for it to be continuous, what do we need? F of a should be equal to limit x tends to a f of x, and f of x is what? 2 minus x upon a whole to the power tan of pi x by 2a. Right. Now over here you can see there is power. I want to get rid of this power. I will be applying log both sides. I am going to get log of f of a equals, now log is a continuous function, so log of the limit is limit of the log, limit x tends to a. This is tan of pi x by 2a into log of 2 minus x by a. Right, so the power is going to come ahead of log. This is the power log of this. Fine. Now you can see over here, if I just get rid of this tan and I instead write it as, tan is nothing but 1 upon cot. So I can write tan as 1 upon cot of pi x by 2a. Now over here you can very easily see that this is of the form 0 by 0. So I will be applying the L'Hopital rule. When I differentiate the numerator and the denominator, what is it that I get? I get 1 upon 2 minus x upon a, 1 upon 2 minus x upon a into d by dx of 2 minus x upon a, which is minus 1 upon a. So this is minus 1 upon a whole upon, what is this? This is minus cosec square pi x upon 2a into d by dx of pi x upon 2a, which is pi by 2a. And over here you basically have the limit. Fine. Now if I move ahead, I can further write this as minus 1 upon a into 2 minus x upon a. This thing divided by this expression means multiplied by 1 upon cosec square pi x by 2a, and this is 2a by pi. So from here you can see a cancels out, minus minus cancels out, you're left with 2 by pi, and here you have sine square pi x by 2a, sine square pi x by 2a whole upon 2 minus x by a. When you apply limit x tends to a in here, you basically get limit x tends to a, this becomes what? This is a, so pi a upon 2a, that is pi by 2, which is 1. So you get 2 by pi into 1 upon, again x tends to a, so you get 2 minus 1, again 1. So this is 2 by pi. Fine. If you are getting log of f of a is 2 by pi, what is f of a? It is e to the power 2 by pi, right? Because if you take exponential, you basically get e to the power 2 by pi, and here you are left with f of a. Fine. So f of a turns out to be e to the power 2 by pi. Let's look at the next question. In the next question, what is it that we are going to have? Let's see. Okay. So the next question says ax cube plus x square minus a plus 2x plus a whole upon x minus 2. Let's talk about this question now. It is saying this is continuous at x equals 2 then. Now the moment I am saying this is continuous at x equals 2, that means limit x tends to 2, f of x is equal to f of 2. Limit x tends to 2, f of x to be equal to f of 2, that means this limit is existing, right? For this limit to exist, limit x tends to 2, this particular expression's limit is existing as x approaches 2. For this to exist, definitely x minus 2 should be a factor of the numerator, right? X minus 2 is a factor of ax cube plus x square minus a plus 2x plus a. Factor of this means 2 is a 0 of this. That means in place of x, if I put 2, I am getting 0, right? So you get 8a plus 4 minus 2a minus 4 plus a is 0. Minus 4 plus 4 cancels. You are left with 8a minus 2a, that is 6a, 6a plus a, that is 7a is 0, or I can say a has to be 0 for this function to be continuous at x equals 2. Fine. Looking at the next question, we have fx is defined on 0 to pi by this particular branch function. Definition: if f is continuous on 0 to pi, then what is the value of a and b? Obviously, we are to check the function's behavior on these breaking points, which is pi by 4 and pi by 2. If I talk about f of pi by 4, f of pi by 4 is actually equal to pi by 4 plus a into root 2 into sine of pi by 4. Sine pi by 4 is 1 by root 2, root 2 cancels, you are left with pi by 4 plus a. Value of the function at pi by 4 is same as limit as x tends to pi by 4 of the function, right? So what is limit? X tends to pi by 4 f of x. Both of these will be equal. So as x is approaching to pi by 4, I am getting 2x cot pi by 4 plus b, that is 2 pi by 4 cot pi by 4 plus b. Cot pi by 4 is 1, so you are left with 2 pi by 4 plus b, which is pi by 2 plus b. Both of these are equal because the function is continuous at pi by 4, so you are getting pi by 4 plus a equals pi by 2 plus b, or a minus b is pi by 2 minus pi by 4, which is pi by 4. Similarly, if I talk about value of the function at the next point, that is pi by 2, if I take it over here, what is it that I am getting? Cot pi by 2 is 0, so I am just getting b. So f of pi by 2 is b. And if I talk about limit x tends to pi by 2 of f of x, it is actually this. So it is a cos 2 pi by 2. So it is a cos pi. Cos pi is minus 1, so this is minus a. And sin pi is what? This is pi by 2. So sin pi by 2 is 1, so this is minus b. So minus a minus b. Again, both of these are equal because the function is continuous at pi by 2. So you are getting b equals minus a minus b, or 2b is minus a. If 2b is minus a, so see we have two relations in a and b, so obviously I can compute a and b now. So if 2b is minus a, or I can say that b is minus a minus b, that means a is minus 2b. So minus 2b minus b is pi by 4. So minus 3b is pi by 4. B is minus pi by 12. If I am getting b is minus a minus b, I am getting b plus b, that is 2b is minus a, or a is minus 2b. Right? If a is minus 2b, I am getting minus 3b equals pi by 4, so b is minus pi by 12. And in that case, a is what? Minus pi by 12 equals minus a, so a is pi by 6. So a turns out to be pi by 6 and b turns out to be minus pi by 12. Clear? Let's talk about this now. If limit x tends to 0, this function exists and is finite. So it's very important to realize when can you say that the limit of a function at a certain point is finite. What do you think? Over here, let's try to understand how are we going to evaluate this limit. This is a sin x. I can just talk about the expansion of sin x. It is x minus x cubed by 3 factorial plus x to the power 5 by 5 factorial and so on, minus bx plus cx square plus x cube whole upon, you have 2x square log x, log of 1 plus x, its expansion is x minus x square by 2 plus x cube by 3 and so on, minus 2x cube plus x to the power 4. So here if you see, you basically have ax minus bx, so a minus b x, then you have plus cx square, and then talking about x cube, you have minus a by 3 factorial x cube and 1 x cube. So you have 1 minus a by 3 factorial x cube, right? After that you have what you have, whatever, fine. And in the denominator you have what? 2x cube minus 2x cube, 0. Then you have minus x to the power 4 plus x to the power 4, 0. You have literally now 2x to the power 5 by 3, 2x to the power 5 by 3 plus and so on. The aim basically is to realize that this limit is actually turning out to be finite. If this is turning out to be finite, I am having x to the power 5 in the denominator, I should have x to the power 5 in the numerator as the first non-zero power. And therefore, this has to be 0, this has to be 0, this has to be 0. So this is finite if and only if a minus b is 0, c is 0, and 1 minus a by 6 is 0. That means c is 0. This means what? 1 equals a by 6 or a equals 6, but a is equal to b, so a equals b equals 6. So this limit will be finite when a is 6, b is 6. So a equals b, a is 6, b is 6 and c is 0. Clear? Let's move on to the next. We have the equation has at least one root in which interval. So this equation is given to you, this has one root in which interval is the question asking. Okay, if I talk about this function sin x minus x plus 1, if I take that as f of x, which is sin x minus x plus 1, in that situation if I talk about f of 0, it is sin 0 minus 0 plus 1, which is 1, that is positive. And if I talk about f of 3 pi by 2, it is sin of 3 pi by 2 minus 3 pi by 2 plus 1, which is minus 1, minus 3 pi by 2 plus 1, which is minus 3 pi by 2, less than 0. If f of 0 is positive, f of 3 pi by 2 is negative, by intermediate value theorem, what is it that is true is there exists some alpha belonging to 0 to 3 pi by 2 such that f of alpha is 0. That means yes, there is a root existing of this function in 0 comma 3 pi by 2. So corresponding to A, you are going to shade R. Similarly, if I talk about B, you are going to see if you take this as your function, f of x, then f of minus 2 will be positive and f of 1 by 2 will be negative, and therefore by again intermediate value theorem there exists a root of this function in this interval. So corresponding to P, you will be shading P. If I talk about the third one, if you take this as your function, in that situation if you take this as your function, you basically are going to get that function at minus 2 will be giving you a negative answer, and at 2 it will be giving you a positive answer. Sign change is happening, and therefore in this interval definitely there will be a point where this function will be cutting the x-axis, and that is going to give you the root of this function. So corresponding to C you will be shading S, and similarly corresponding to D it will be this interval, because at 0 this is negative, at 1 this is positive, so somewhere in between it will be 0 definitely. So a root is existing in this interval, that is Q. Continuous use of the intermediate value theorem, nothing else. Then you have for f to be continuous, f of 0, for f to be continuous, f of 0 is given by what? For f to be continuous at 0, limit x tends to 0, f of 0 should be equal to, limit x tends to 0, f of x should be equal to f of 0. So f of 0 will be what? Limit x tends to 0, f of x, this is the first f of x, log of 1 plus 4x upon x. Just if I have a 4 over here, I can say this limit is 1. For 4 over here, I will have to adjoin 4 over here. So I will be left with 4 times, this 4 can come out, 4 times limit x tends to 0, 1 plus 4x by 4x, which is 4 into 1, that is 4. So corresponding to A, I will be shading R. Then next you have log of, let's see, limit x tends to 0, log of 4 plus x minus log 4. Log m minus log n is log of m by n. 4 plus x by 4. 4 plus x by 4 whole upon x. This eventually gives you limit x tends to 0, log of 1 plus x by 4. I again want only x by 4 in the denominator, I already have x. So if I divide by 4, I'll have to multiply by 4 over here, or complete 1 by 4 can be brought outside. Again this is 1, your answer is 1 by 4 into 1, which is 1 by 4. So corresponding to this you will shade P. Clear? Let's move on to the next one. We have 1 upon sin x minus 1 upon tan x. So it is nothing but limit x tends to 0, 1 upon sin x minus 1 upon tan x, that is cos x upon sin x. So you basically have 1 minus cos x whole upon sin x, that is limit x approaches 0. You can see this is 0 by 0 form. Apply the L'Hopital rule. What is it that you have? You have minus sin x upon cos x, and this is limit x approaches 0. And this comes out to be nothing but 0, so you shade Q. Then you have the last one, 1 minus cos cube x upon x into sin 2x. Let's see. 1 minus cos cube x, a cube minus b cube. 1 minus cos x, 1 plus cos x plus cos square x whole upon x into sin 2x. Now I know sin 2x by 2x is 1 as x approaches 0. So I want 2x over here, so I will be multiplying also by 2x. This is going to become 2x square. Right? So now you have 1 minus cos 2x, that is 2 sin square x by 2 whole upon 2x square. This gets cancelled out. Then you have 1 plus cos x plus cos square x whole upon sin 2x by 2x. Now here also I want x by 2, so I'll just divide by 4 and multiply by 4, or basically take it over here. Now I'm left with sin x by 2 upon x by 2 whole square, limit as x approaches 0, 1 by 4 is outside. And here again you have, you know, limit of the product is product of the individual limits. Limit x approaches 0, 1 plus cos x plus cos square x whole upon limit x approaches 0 sine 2x by 2x. Very easy. This is 1, this is 1, this is 1 plus 1 plus 1, 3. So 1 by 4 into 1 into 3 by 1, that is 3 by 4. So our answer is S. Fine. Let's move on to the next one. We have, this is my statement given to me. It says that limit of this expression is 100. Okay. And statement 2 says a general very description that if px and qx are polynomials of same degree, then limit x tends to infinity px by qx is the limit x tends to infinity leading coefficient of px upon leading coefficient of qx. Let's talk about general two polynomials of same degree, px and qx. An x to the power n plus an minus 1 x to the power n minus 1 plus and so on a naught, or let me take this as a naught, this as a1 and so on, this as an, and qx again I am taking as b naught x to the power n plus b1 x to the power n minus 1 plus and so on bn. If I talk about px by qx, what happens? I can take out x to the power n common. When you take out x to the power n common, what are you left with? A naught plus a1 by x plus a2 by x square plus and so on an upon x to the power n. Similarly, from the denominator also, when you take out x to the power n common, you are left with b naught plus b1 by x plus b2 by x square plus and so on bn by x to the power n. Okay. So when you apply limit x tends to infinity in here, what you are left with is, this gets cancelled, limit x tends to infinity, this becomes 0, 0, 0, 0, 0, 0, you are just left with a naught by b naught. And a naught is leading coefficient of p, b naught is leading coefficient of q. So yes, limit x tends to infinity px by qx when p and q are polynomials of same degree is leading coefficient of px upon leading coefficient of qx. So yes, statement 2 is very much true. Now using statement 2, if you go above, the numerator you can see is actually playing the role of px. It is a polynomial of degree 10 with leading coefficient 100. And this is playing the role of qx, it's a polynomial again of degree 10 with leading coefficient 1. So both are polynomials of the same degree 10, leading coefficient of px is 100, leading coefficient of qx is 1. So 100 upon 1 is the answer, which is 100. So yes, statement 1 and statement 2 both are true, and statement 2 is actually giving the correct implication for statement 1. So statement 1 is true, statement 2 is true, and statement 2 is correct explanation for statement 1. Clear? Let's move on to the next question. We have the value of 1 by 32 times f of 0 for which fx is continuous is what? Let's see. Here I am saying f of 0 will be limit, this is f of 0's value we are evaluating, limit x tends to 0 f of x. F of x is 512, so 512 straight away will come out. You are left with under root x plus 4 minus 2 whole upon sine 2x. Fine. Here what you can do is, just to solve, you can rationalize. Right. So you have 512 limit x tends to 0, a minus b, a plus b is a square minus b square whole upon sine 2x into root over x plus 4 plus 2. Right. So what you do is 512 limit x tends to 0, let's make it 2x upon sine 2x, and here you have 1 by 2 into 1 upon root over x plus 4 plus 2. So you basically get 256, I've cancelled this out. Limit x tends to 0, 2x by sine 2x is 1, and limit x tends to 0, if you put it over here, this is 1 by 4. So you get what? 64. F of 0 is 64, so 1 by 32 times f of 0 is 1 by 32 into 64, which is 2. So the integer associated to this question is 2. 32 into 2 is 64. Next you have given the function this, x greater than 0. Suppose f satisfies this equation, then k will be equal to what if f is satisfying this equation? So okay, let's consider f of x. This is limit n tends to infinity, x to the power 1 by n minus 1 into n. I can write this alternatively as this, so that power of x and denominator are exactly the same. Now I can say 1 by n if you consider as u, as n tends to infinity, 1 by n tends to 0. So limit n tends to infinity gets converted to limit u tends to 0. X to the power u minus 1 whole upon u, and you know this is nothing but log x. So fx is coming out to be log x. What is f of 1 by x? It is obviously log of 1 by x, which is log 1 minus log x. Log 1 is 0, so you just have minus log x. When you incorporate these values over here, you get 7 times f of 1 by x. So 7 times minus log x plus k times log x equals 0, isn't it? Minus 7 times log x, because f of 1 by x is minus log x. So you have minus 7 times log x plus k times log x. So this is log x minus 7 plus k is 0. So you basically get k equals 7. Are you understanding? You get k equals 7. K is equal to the integer 7. Let's look at the next question. We have, if limit x tends to 0, x into this expression minus b sine x whole upon x cube is 1, then a and b are what? What is the relation they basically satisfy? So let's understand, this is limit x approaches 0, x into 1 plus a cos x. Now cos x can be written as 1 minus x square by 2 factorial plus x to the power 4 by 4 factorial and so on, minus b sine x, which is x minus x cube by 3 factorial plus x to the power 5 by 5 factorial and so on. Fine, whole upon x cube. Just open this up, you get what? X is outside, 1 plus a minus ax square by 2 factorial plus ax to the power 4 by 4 factorial and so on. So x is only multiplied by this, minus bx minus bx cube by 3 factorial plus bx to the power 5 by 5 factorial and so on, whole upon x cube. Now if you see, you basically are left with, let's open this up completely, this is x plus ax minus ax cube by 2 factorial plus ax to the power 5 by 4 factorial minus and so on, minus bx plus bx cube by 3 factorial minus bx to the power 5 by 5 factorial and so on, whole upon x cube. So now you have, this is x, this is ax and this is minus bx. So you have 1 plus a minus b. You have 1 plus a minus b x, fine, 1 plus a minus bx. Then you have x cube basically. So you have b by 6 minus a by 4. x cube you have. This is minus a by 4. This is minus a by 2, not 4. This is 2. 2 factorial is 2 and 3 factorial is 6. So you have minus a by 2 plus b by 6. This is what you have, x cube, and after that you have what? This is plus a by 4 factorial and this is minus b by 5 factorial, but we don't need all that. Why? Because denominator there is x cube. Fine, denominator there is x cube, I don't need anything else. Why I don't need anything else? Denominator is x cube, limit is going x tends to 0. See, minimum that I need is x cube over here. After that everything else is going to become 0, because when you take out x cube common, in x to the power 5 x square power 2 will be remaining. When x approaches to 0, that is going to make the entire expression 0. So till x cube I need the expressions, but if this limit is finite, 1 minus a, 1 plus a minus b will have to be 0, and because this limit is 1, that means this expression will have to be 1. So b by 6 minus a by 2 will have to be 1. This has to be 0 and this has to be 1, only then can this limit be finite first of all, and this limit can be equal to 1 second of all. So from here you are getting that b is 1 plus a. If b is 1 plus a, so you are getting 1 plus a by 6 minus a by 2 equals 1. Or you are getting 1 plus a minus 3a equals 6. So you are getting 1 minus 2a equals 6. So you are getting 1 minus 6, that is minus 5 equals 2a, or a is minus 5 by 2. If a is minus 5 by 2, what is b? If a is minus 5 by 2, 1 minus 5 by 2, that is 2 minus 5 by 2, that is minus 3 by 2, minus b equals 0. So b is actually what? So see, what I am saying is 1 plus a is minus 5 by 2. A is minus 5 by 2. Minus b is 0, which implies b is this, isn't it? B will be 2 minus 5 by 2, which is minus 3 by 2. So you are getting a to be minus 5 by 2 and b to be minus 3 by 2. That is what you are getting as your values, right?